my dear students, welcome to IMS GATE Academy. Excellent practice question series regarding communication system subject. So earlier we have discussed various questions regarding the first chapter. So far whatever the questions we have discussed in the previous sessions regarding amplitude modulation and SSB-SC, we have discussed variety of questions, right? So whoever couldn't attended those sessions in live or might not watch those lectures, okay, so kindly watch those lectures whenever you get some time. So all the lectures will be available in the playlist of excellent practice question series regarding communication system subject in our YouTube channel. You can just check the playlist. So whatever the lectures we have covered earlier, so kindly watch all those lectures in your free time, right? So in this particular session, we are going to start the questions regarding the next topic of first chapter, that is SSB-SC. So in this particular session and in the next week, we will be having one more session. So in these two sessions, I will discuss the variety of questions related to the SSB-SC concept, and this concept is also common for two branches, EC and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So I hope all of you will quickly share this video link with all of your friends. This is the MSQ question. This is the MSQ question. So just look at the question and after that look at the choices. Here for this question, either one option or more than one option can be correct. So you have to choose all the correct options. All of you give it a try. So here if you read the question, which are the following amplitude modulation schemes, will have equal bandwidth? Here they have given four choices, right? In each option you are having one modulation technique. So among all these modulation techniques, whichever modulation techniques are having equal bandwidth, those will be the correct options, right? So here SSB-SC. In SSB-SC, we are having the bandwidth as FM. Whereas in DSB-SC, here we are having double sideband. That means both upper sideband and lower sideband we are having, whereas carrier is suppressed, right? So here we are having the bandwidth as 2 times FM. In the vestigial sideband, we are having one of the sideband completely and part of the other sideband also we are having. Yeah, Naveen Kumar, good afternoon. So in the vestigial sideband, we are having one sideband completely and the part of the other sideband we are having, right? So that means since we are having one of the sideband completely, so because of that we will get FM, and part of the other sideband also we are considering. So because of that, we can consider the bandwidth of VSB-SC as FM plus FE, FM plus FE. Now, the last one, can you guess what is the bandwidth for this last modulation technique? For the last modulation technique, what is the bandwidth? DSB with carrier. Naveen, any guess? Yeah, you will get only the second term. First term won't come. So here we are having double sideband with carrier. See, just like this one. Here we are having double sideband. As the name implies, double sideband means we are having upper sideband and we are having lower sideband. We are having two sidebands. Okay. So regarding upper sideband, you will be having cutoff frequency like FC plus FM, and regarding lower sideband, you will be having FC minus FM. So when you are having normal frequency line like this, okay, so here you will be having center frequency, that is a carrier frequency. Now you are getting two frequencies, right? So FC plus FM you will get here, FC plus FM you will get here, and FC minus FM you will get here. Because when you compare with FC, FC plus FM is what? Greater, right? Similarly, when compared to FC, FC minus FM is what? Smaller, right? So on the normal frequency axis, you can represent like this. Center frequency is FC, and greater than that, you can represent above that, okay, or towards right hand side. And similarly, lower than that, you can represent towards left hand side. Okay. Now, so from FC to FC plus FM, whatever the band of frequency we are having, that is the upper side band. Okay. And from FC minus FM to FC, we are having from FC minus FM to FC, we are having lower side band. So when you draw the spectrum, here at FC plus FM you are getting the strength, and similarly at FC minus FM we are getting the strength, whereas at FC we are not getting any strength. Okay, then that one we will call it as double sideband suppressed carrier. Okay, so here I have represented for generalized case. If it is a single tone, this is the upper sideband frequency and this is the lower sideband frequency. Okay, so range of frequencies over which the signal was present, that range of frequencies is nothing but bandwidth. Okay, so here double sideband suppressed carrier. So we are having both the sidebands. Together. Bandwidth means upper cutoff frequency minus lower cutoff frequency. Okay, or other words, from FC here FM units you are having. Similarly from here FM units you are having. Together FM plus FM 2FM. FM plus FM 2FM. Right. Whereas whatever the logic we have discussed here for option B, similar logic will applicable. Okay. Only difference, here you are having both the sidebands, and along with that at carrier frequency also you are getting the signal component. Okay. So that means obviously when you look at double sideband suppressed carrier and double sideband with carrier, upper frequency and lower frequency remains same. Upper frequency, lower frequency remains same. So bandwidth you will get same. Is it clear, Naveen? Up to this point. Regarding double sideband with carrier also, you will get 2FM only. You will get 2FM. Yes, very good. So here the question is, among these four modulation techniques, whichever having equal bandwidth, those are the correct options. This is the MSQ question, either one option or more than one option can be correct. So here for this question, two choices are correct, option B and option D. Option B and option D. Right. Next question, all of you give a try. This is the this is the MCQ question. Okay. Here the question is regarding power saving. Power saving in DSB-SC and SSB-SC with respect to or when compared to AM, which has modulation index of 0.5. So all of you give a try. Yeah, Naveen, you can cross check once. So here the question is how much power we are able to save in DSB-SC and SSB-SC when compared to the AM, right? So first of all, if you consider AM, there the amount of power required for transmitting the AM signal is PT equal to PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. Suppose if you are splitting this one, you will get two terms like this. PC plus PC into mu square by 2. PC into mu square by 2. And if you further split, the first term I am copying as it is, and second term you can write into two terms like this. PC mu square by 4 plus PC mu square by 4. So when you are adding these two times PC mu square by 4, that is nothing but PC mu square by 2, right? So that means what is your observation? Here you are having the carrier power, and here you are having upper sideband power, and here you are having lower sideband power. So AM is nothing but you are having both the sidebands, and along with that you are having the carrier component. So that is nothing but double sideband with carrier or double sideband full carrier. Okay. So this is the total power required. Now DSB-SC, double sideband suppressed carrier. Double sideband suppressed carrier. As the name implies, here we are suppressing the carrier. Here we are suppressing the carrier. So that means this much amount of power we are saving. This much amount of power we are saving when you are using double sideband suppressed carrier, right? So here eta is nothing but eta is the efficiency, but here for the question they are asking power saving, right? So you can write regarding power saved in DSB-SC, power saved in DSB-SC. So here the carrier power we are saving if you are using the double sideband suppressed carrier. Okay, and they are asking with respect to what? AM. So this entire power you can consider here in the denominator. So regarding this, already we got the simplified version, this one. So you can use this formula, PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. So here PC will get cancelled. So if you want, you can do the LCM here. So you will get 1 divided by, here LCM is 2 plus mu square. 2 plus mu square. If you rearrange, this 2 will come into the numerator. So you will get 2 by 2 plus mu square. 2 by 2 plus mu square. So in the question they have given mu value they have given 0.5. So just substitute here. So all of you just do the simplification and tell me how much value you are going to get here. Yes, very good Naveen, very good. Yes, you will get 0.8888 like that you will get. So this one in terms of percentage, if you write, you can write 88.88%. So what are the normal value you got? Okay, because options you are having in terms of percentage, what are the normal value you got, you can represent in terms of percentage, right? Yes. So regarding DSB-SC, the amount of power saved is 88.88%. So regarding 88.88%, we are having only in one choice. So obviously you can choose option C. Option C you can choose. Here in option A also you are having this one, but here, okay. But according to the question, DSB-SC is the first. So in the options also, regarding that, you should have the corresponding value in the first column, right? So only option C is having 88.88% regarding the first column. So directly you can choose. Now obviously this one will be correct. Whether it is correct or not, let us verify. Now regarding SSB-SC, so here as the name implies, here we are using only one sideband, single sideband, and carrier also we are suppressing the carrier. Now you can observe, like here you are having carrier component and you are having upper sideband, lower sideband, but in this modulation technique, according to your requirement, you can use only this one or only this one. Either of these two sidebands are sufficient, right? So say for example, if you are using any one term, because both the powers are same only, right? Say for example, if you are using LSB example, okay, so that means in this SSB-SC modulation technique, you have saved this power and you have saved this power also, right? This much power you have saved. So here power saved equal to PC plus PC mu square by 4 divided by total power required for AM, same. Whatever the denominator you have considered, same thing. PC into 1 plus mu square by 2. So in the numerator you can take PC as common. Then you will get PC into 1 plus mu square by 4 divided by PC into 1 plus mu square by 2. So here PC will get cancelled. You will get 1 plus mu square by 4 divided by 1 plus mu square by 2. So substitute mu value same 0.5, mu value 0.5, 1 plus 0.5 whole square divided by 4 divided by 1 plus 0.5 whole square divided by 2. Just do the simplification, you will get 0.9444, you will get 0.9444. So this one in terms of percentage you can represent as 94.44. 94.44. Yes, we are getting the same answer, 94.44 regarding SSB-SC. So all of you give a try. This is the question asked in GATE EC 2005 for 1 mark. Yes, very good Naveen, very good. So here the question is, you are having various modulation techniques here. So among all these modulation techniques, which modulation technique require minimum transmitted power? Regarding the power required for transmitting any particular signal here, among all these signals, which signal require minimum transmission power and which modulation technique requires minimum channel bandwidth? So with respect to bandwidth and with respect to power, it should be minimum. Okay, so whichever option satisfies, that will be correct. This is the MCQ. Obviously one option will be correct, right? So here you can make 2 columns. So the first column is like transmitted power or total power PT. Total power PT. And the other column you can mention regarding the bandwidth. Regarding the bandwidth. So first let us see regarding the bandwidth. So in VSB-SC we already mentioned the bandwidth is FM plus FV. FM plus FV. In DSB-SC it is 2 FM. And in SSB-SC it is FM. In AM we are having 2 FM. Okay, in the first question also we have discussed regarding bandwidth. Okay, this question based on bandwidth and power, whereas the first question which we have discussed, that is purely based on bandwidth. The first question whatever we have discussed, that is with respect to bandwidth, and second question whatever we have discussed, that is with respect to power. And now this question based on both. the power and bandwidth. Now with respect to bandwidth, when you look at, okay, here among all 2FM is the maximum one, 2FM is the maximum. Okay, after that just compare FM plus FE is slightly lesser, and FM is, among all FM is the minimum, right? So with respect to bandwidth, minimum bandwidth you are having in SSB-SC. With respect to bandwidth, SSB-SC is having the minimum. Okay, now let us see whether SSB-SC is having minimum power or not. Okay, so here regarding AM, the total power required, earlier we have seen we are having the carrier power, we are having the upper sideband, we are having the lower sideband, right? So here we are having carrier power, upper sideband power and lower sideband power. Okay, now double sideband suppressed carrier, their carrier we have suppressed, that means you are having both the sideband power, whereas in SSB-SC we are considering only one of the sideband, either upper sideband or lower sideband, right? So either upper sideband power or lower sideband power, any one of the power. So here in VSB-SC we will consider either upper sideband or lower sideband will consider. Whenever you are considering one sideband completely, the part of the other sideband will consider. Like suppose here upper sideband for the timing I am considering, along with that some part of the lower sideband I am considering, that is nothing but PV, vestigial sideband power. Or similarly if you are considering lower sideband completely, regarding the upper sideband, some part of the power we are considering, some part of the upper sideband we are considering, regarding that the power is PV. Okay, so now when you look at all these equations, this is having more value or maximum value you can say. When compared this one, this is less. Okay, when compared this one, this is less, and among all this one is less. Both the values are same, right? When you look at all the four equations, SSB-SC with respect to power and with respect to bandwidth, both the values are getting minimum with respect to SSB-SC. That is the reason in general we will recommend SSB-SC. Okay, when you are looking with respect to transmitted power and bandwidth. So according to requirement and application, okay, we will use the respective modulation technique. Each and every modulation technique we are having the respective application. According to the requirement and application we can use accordingly. So the next question, which is asked in GATE EC 2006 for 2 marks. So all of you give it a try. This is a very interesting question. This question is based on SSB-SC and narrowband FM. Actually the narrowband FM you will study in the second chapter. Okay, this question based on the concepts of first chapter and second chapter. So all of you give it a try. Any guess? Yes, very good Naveen, very good. Option B is the correct answer. Yes, very good. You are from which branch? And currently which year BTech you are studying, or whether you completed BTech? Yeah, in this question you are having the message signal which is having the bandwidth 10 kHz, which is having the bandwidth 10 kHz, and here, so that means this 10 kHz is nothing but FM. FM is nothing but 10 kHz. Bandwidth of the message signal is nothing but the maximum frequency of that particular message signal. Both are same. So this 10 kHz is nothing but FM. FM, right? And here they have mentioned the carrier frequency as 10 power 6 Hz. Carrier frequency they have given 10 power 6 Hz. And here they have mentioned that the message signal and carrier signal, whatever they have used in order to get SSB-SC modulation. SSB-SC modulation, and here they have mentioned lower sideband. So when you are using any one of the sideband, and here strictly they have mentioned it is a lower sideband, right? Yes, very good. You are from EC, recently passed out. Okay, right. So regarding excellent practice question series, earlier we have discussed regarding AM and DSB-SC. So kindly watch those series of lectures in your free time. And similarly, in the last few months back, we have discussed the foundation course regarding the digital circuit subject. So there, those lectures also you can watch. Okay, these lectures will help you a lot in the coming GATE exam, right? So all the playlists you can just check in our YouTube channel, IMS GATE Academy. So whichever playlists are relevant for your branch regarding EC branch, so kindly watch those series of lectures, whichever you have missed earlier, so that you can get benefit from those lectures, right? So earlier we have discussed regarding foundation series. So currently we are discussing the like two kinds of series. Like one is excellent practice questions, another one is most important concepts, right? So whichever subjects are related to EC branch, so regarding that, whatever the playlists we are having in our YouTube channel, so kindly watch all those lectures, right? So here if you consider regarding SSB-SC modulation, and here strictly they have mentioned it is a lower sideband. So lower sideband means here you will be having the center frequency FC, okay, upper cutoff frequency is FC plus FM, but here lower sideband they have mentioned, so the lower cutoff frequency, that is FC minus FM. So this is the LSB, this is the LSB. We are considering the lower cutoff frequency as FC minus FM, and from there the upper cutoff frequency is carrier frequency, that is FC. Yeah, thank you Naveen. I hope you understood everything, right? Yes, very good. So FC minus FM to FC. So here when you look at this particular signal, FC minus FM is the minimum value, whereas FC is what? Maximum value. FC is the maximum, right? So regarding FC, according to the question, we are having 10 power 6 Hz. 10 power 6 Hz. So in this particular LSB signal, this FC is the maximum frequency. This FC is the maximum frequency. Okay, maximum frequency. So 10 power 6 Hz we are having. Now, whatever the SSB-SC we got, now this particular signal they have passed through narrow band FM. Okay, so narrow band FM is nothing but it is similar to your AM only. In the AM we are having both the sidebands, and along with that carrier we are having, right? Similarly in the narrow band also you will get both the sidebands and you will get carrier, okay? But only the difference regarding upper sideband, regarding carrier component, whenever you are drawing the magnitude spectrum, you will get the similar spectrum. Whereas regarding lower sideband, you will get 180 degrees out of phase. That is the only difference. That means here you will get just like in the double sideband, or you can say double sideband with carrier or AM signal, there you will get three frequencies, right? FC, FC minus FM, FC plus FM, right? Similarly here you will get, okay, you will get those three frequencies. Similarly you will get those three frequencies. That means whatever the bandwidth you will get in AM, similar bandwidth you will get in narrowband FM. Okay, similar bandwidth you will get in narrowband FM, right? But here the carrier frequency is this one, FC2, and here in this particular example, the message signal is what? Message signal maximum frequency is this one. So for that narrowband FM, this LSB, whatever SSB-SC modulation we have done, that is the input signal. That is the input signal. Okay. So now they have used narrowband FM. Regarding narrowband FM, they have given the cutoff frequency as, earlier they have mentioned FC1. Okay. So in this example I have mentioned like FC. So for generalized, for this question if you are making, so that is FC1. Okay. So FC2 they have given 10 power 9 H. 10 power 9 H. So 10 power 9 we can write as 1000 into 10 power 6. 1000 into 10 power 6, because earlier we got in the order of 10 power 6. That is the reason I am converting accordingly in multiples of 10 power 6. So 1000 into 10 power 6 H. So in the narrowband FM we will get the frequencies like this, FC2 minus FM. Okay, so with respect to this one I am telling, so F max. Okay, FC2 minus F max, you will get FC2 and you will get FC2 plus F max. FC2 plus F max you will get. Okay, right. So that means from here to here, okay, whatever the range of frequency you are getting, just you can multiply with 2. That is nothing but bandwidth. Otherwise you can subtract this one from here, and from there also you will get bandwidth. Accordingly, whichever method you are getting convenience, you can follow accordingly, no problem. So here for the timing I will consider like this. Say for example FC2 plus F max I am considering. FC2 is this one, FC2 is this one, and FC2 plus F max. Okay, I will write here. Bandwidth equal to 2 times F max. Okay. See, when you are considering bandwidth, upper cutoff frequency minus lower. Upper cutoff frequency minus lower. So upper cutoff frequency is FC2 plus F max minus lower cutoff frequency is FC2 minus F max. FC2 minus F max. So here FC2 will get cancelled. Minus of minus is plus. So F max and F max you can add. So you will get 2 times F max. 2 times F max, where F max is nothing but what? 10 power 6 H. So you can substitute here 2 into 10 power 6 H. This is the bandwidth of narrowband FM for the given question. So option B is the correct answer. Option B is the correct answer. I hope it is clear. Just like for AM we have mentioned earlier, regarding AM the bandwidth we are getting 2 FM, right? In the same way, regarding narrowband FM also, bandwidth you will get same. Okay, 2 times FM. 2 times FM. Okay, but here in this question FM is nothing but whatever the SSB-SC output we got in that particular spectrum, whatever the maximum frequency we are having, that one we have to consider. That's all. Okay, I hope it is clear. Now let us see the next question. All of you give a try. This is the question asked in GATE EC 2009 for 1 mark. See, in this question they have given the message signal m of t equal to message signal they have given m of t equal to cos 2 pi fm into t. Generally you will be having am cos 2 pi fm t. Okay, but in this question they have given cos 2 pi fm t. Yeah, Naveen, it is not the correct. Okay, I will discuss, no issue. Okay, so here you are having message signal as cos 2 pi fm into t. Okay, and here you are having carrier frequency they have given fc. In general they will represent like ac cos 2 pi fct. Okay, if you want you can consider sine or cos, no problem, right? So which of the following represents a single sideband, that means SSB-SC only. Okay, generally they will represent SSB-SC, sometimes they will represent SSB, but from here also you can easily understand which is having only one sideband, single sideband. That means obviously the other sideband is suppressed and the carrier also suppressed, right? So no need to have any confusion whenever they represent regarding SSB or VSB also. Sometimes they will mention after that SC, sometimes they won't mention. Whether they mention or not mention, the meaning wise it is not changing, right? Now let us see, okay, option by option. Which one here, whatever the equations we are having, now let us try to identify in each option whatever the equation they have given that belongs to which signal or which modulation. Okay, so okay, for the timing just consider option B. Regarding option B, you are having what? Cos 2 pi fct. It is something like AC cos 2 pi fct. So that means it is only carrier signal. It is representing carrier signal. Just like here, message signal they have given cos 2 pi fmt. Our generalized equation will be am cos 2 pi fmt, right? Similarly here, option B represents carrier signal. Option B represents carrier signal because it is having the carrier frequency fc. It is having frequency fc, right? Now regarding here option D, if you observe, this is the standard equation of option B. This is the standard equation of your AM. This is the standard equation of AM signal. See, you can just observe AC into 1 plus Ka m of t into cos 2 pi fmt into cos 2 pi fct, right? So this is the standard equation of AM. So here if you carefully observe, okay, if you want you can split 1 into cos 2 pi fct. So that means from there you are getting what? Carrier component. Yes, very good Naveen, very good. And when you multiply these two, you are getting cos 2 pi fmt into cos 2 pi fct. So from here you are getting both the side bands and from here you are getting carrier. So whenever you are having both the side bands along with the carrier, that is nothing but your AM. Now if you are removing carrier component, whatever rest of the term you are having, that is nothing but what? Double sideband. You can observe cos 2 pi fm into t into cos 2 pi fct. This is nothing but double sideband suppressed carrier. Right? So if you observe other than option C, regarding remaining three choices, in one choice you are getting AM, in one choice you are getting DSB-SC, in one choice you are getting carrier, right? Obviously these three, any of these three are not matching to SSB-SC. Obviously you can choose option C as the correct one. Even regarding here, you can clearly observe, when I told this is the carrier signal, which is having the carrier frequency as FC. Okay, so in place of FC, you are having what now? In place of FC, you are having FC plus FM. So when compared to FC plus FM is what? When compared to FC plus FM is having high frequency, right? So that is nothing but upper sideband. We can say it is upper sideband, right? So it is the SSB-SC signal. So if you want more clearly, this particular signal is representing USB, upper sideband. Suppose if they have mentioned FC minus FM, that is the lower sideband. Still it is the SSB-SC only, right? So here they have given the question as MCQ. Obviously one choice will be correct. Okay, if they want to frame the same question as MSQ, they can give the choices like this. Okay, so like option A, whatever they have given, that same thing. Option B, same thing. Option C, same. Okay, say for example, I am repeating once again. Option A, whatever they have given, cos 2 pi fm into t, cos 2 pi fct. option B cos 2 pi fct, option C cos 2 pi into fc plus fm into t, and option D, suppose if they have given like this and if the question is MSQ, then which options you will choose? Same question, but I have modified as MSQ. Any guess, Naveen? Same question regarding SSB-SC only. Now, if you are having choices like this, which choices you will choose? Yes, very good. C and D are correct. Yes, very good. C and D both are correct, because here it is representing Fc plus Fm. It is the upper side band. So here you are getting SSB-SC. In that you are getting upper side band. Similarly, here you are having Fc minus Fm. It is a lower side band. So that means we are sending only one side band. In option C, we are sending only upper side band, whereas in option D, we are sending only lower side band. Here in option B, you are sending only carrier frequency, right? That is the reason I have mentioned here carrier signal. So whatever the carrier signal format you are having, you can closely observe similar format only. In place of Fc, here Fc plus Fm is there, that is the upper side band. In place of Fc, you are having Fc minus Fm, that is the lower side band, like that. Okay. Whenever you are multiplying two cos signals or two sine signals, okay. So whenever the multiplication of two signals, both are sine or both are cos, that equation represents double side band. That means you are getting only two side bands. But in that you are not getting the carrier component. The reason is very simple. I hope by this time you are familiar regarding the trigonometric equations, like 2 cos A cos B is nothing but what? Cos sum plus cos difference. So you are getting one of the frequency as Fc plus Fm, another frequency as what? Fc minus Fm. So that means both the side bands are there. But we are not having carrier frequency, right? Similarly, you will be having like 4 equations, like 2 sin A cos B, or 2 cos A cos B, or 2 sin A sin B, or 2 cos A sin B, like that. Okay, whatever may be the trigonometric equation you are having, you will get either in terms of sine or in terms of cos, like that, or one term can be sine, another term can be cos, etc. But in that sine terms or cos terms, if you closely observe, you will get the pattern like addition of 2 frequency, another one is like subtraction of 2 frequency, right? Addition of 2 frequency represents upper side band, difference of 2 frequency will represent lower side band. Okay, I hope it is clear. Now the last question for today's session. This is the question asked in GATE EC 2011 for 1 mark. This is the match the following question, and it is the MCQ only. Here you are having column 1 and here you are having column 2. Here you are having choices. You try to choose the correct one. Okay, whatever among the given choices, whichever is appropriately satisfying, that one you can choose. So here you're having two columns. You have to match the appropriate one according to the choices. Okay, whichever choice more appropriately you are getting closer, that you can choose. Okay, so here if you observe column 2, if you observe, this is the conventional AM, so that means normal AM, right? And here you're having FM, that is a frequency modulation, here VSB, and here SSB-SC. So whatever column 2 modulation if you observe, other than FM, remaining three belongs to AM, right? AM double sideband suppressed carrier that they haven't given. After that SSB-SC they have given, and then VSB-SC, right? And FM belongs to the angle modulation. Okay, so here you can read one by one and you can choose. Suppose if they haven't given FM, and if you are having only like AM, DSB-SC, SSB-SC and VSB, then definitely regarding power efficient transmission, earlier also we have discussed one of the question, among all the analog modulation techniques, SSB-SC is having the less power or minimum power, right? So with respect to that, if FM is not there, then definitely you will choose SSB-SC, right? So regarding P, if FM is not there, then definitely you will choose SSB-SC. Okay, but here FM is there. Okay, so regarding FM we are having two possibilities, like narrowband FM is there and wideband FM is there. When you are considering narrowband FM, definitely it is the drawback. Okay, narrowband FM is similar to your AM only, But if you consider wideband FM, there you are getting PC, the carrier power only, right? So with respect to that sense, here we are getting two possibilities regarding power. Okay, so now we have to choose whichever is the appropriate. Okay, why I have mentioned here two possibilities, you can easily understand. Okay, for the time being, other than P, if with the help of remaining three, somehow or other, other than FM, if you are able to match, okay, then definitely this FM we can match to this one. That is the reason I have mentioned here. Now just consider Q, most bandwidth efficient transmission of voice signal or speech signal we will transmit. Okay, we will use this particular transmission of voice signal or speech signal, we can use SSB-SC modulation, right? So regarding Q, it is matching to SSB-SC. Okay, voice signal, for transmission of voice signal or speech signal, we will use SSB-SC modulation, right? So now just observe, regarding Q, it is matching to 4. So since it is matching to 4, here you can keep hold. Okay, so for the timing you can keep hold. You can look at here, regarding Q, you are having 4 in 2 choices. So that means option A, option C we can eliminate. I hope it is clear up to this point. With respect to voice signal, we can use among all the modulation techniques SSB-SC, right? And simplest receiver structure. Okay, so obviously the first modulation technique, that is a conventional AM, that is a simple. So regarding R we are having 1. So regarding R, if you observe 1, you are having option B is satisfying. So obviously we can eliminate option D. We can eliminate. Okay, then bandwidth efficient transmission of signals with significant DC component. That means we are sending one sideband completely and part of the other sideband we are transmitting, right? So regarding that we will use VSB-SC, and even VSB-SC modulation we will use for transmission of video signal. Video signal starting frequency is 0 and maximum frequency is 4.5 MHz, right? So with respect to that sense also, when you look at 0, if any signal is having frequency 0, that is nothing but what? DC. So regarding S you will get 3. So regarding S you are having 3 here. Yes. So when all these 3 are matching, so obviously FM is left over. That FM now we can map to P. Okay, so that is the reason option B. Okay, so in this particular session we have discussed variety of questions regarding SSB-SC, and of course we have kept some questions based on AM and DSB-SC also, just to get the overview, right? So I hope all the questions whatever we have discussed in this particular session, it is very much helpful for all of you. So in the next week, okay, on coming Friday we are having one more session. in that party session we will discuss further questions regarding SSB-SC and 1 or 2 questions related to FDM, that is frequency division multiplexing also. Okay, so I hope all of you liked this session. So we'll meet you all in the next session. Thank you everyone.